Ladies and gentlemen, I'm going to speak today on the topic Changing Landscape in Southeast Asia, Impact on Soil and Agriculture. So let me show you the map of Southeast Asia. Maybe some of you have not really know about it. So this is Southeast Asia along the equator. And a bigger map of Southeast Asia is this, 10 countries with one observer, Malaysia. So when I was a student at the University of Malaya in late 1960s and early 1970s, I learned about this. My professor said Southeast Asia was very stable since Quaternary. So if there's a change in sea level, it was not because of tectonic movement, but because of other things, temperature rise or climate change. So let me show you this. There was a study in Greenland. So they determined the temperature many years ago between 8,000 to 20,000 years ago. You see, there's a period of temperature low. And this coincided with ice, glacier. And then there was a period of temperature higher. Then this is interglacial. So this is ice. So when temperature got higher, then the ice melt. Then it will result in sea level rise. Okay, so the highest sea level in Southeast Asia during the late Pleistocene was 50 meters above. And the lowest sea level that went down during that period was 100 meters below the present height. So what happened when this happened? Okay. When the sea level was 50 meters above the present height, there was a period of sedimentation. So evidently you can see this in Southeast Asia. Then when the temperature dropped, we have sea level drop, and there is a period of erosion. Then here we had the formation of riverine terraces. And we see a lot of this evidence in Malaysia, studied by geologists from the University of Malaya, who are then the British, German, American, Indonesia. They were lecturers in the University of Malaya. They were my professor at the time. Then we can see also this evidence in Assad, in Cambodia. I was an examiner of PhD thesis from a university in Australia. I read about this, and he mentioned about this. So this is my drawing. So you will see these riverine terraces in the area where we have sedimentation. So there was a lecturer in Universiti Malaya, Sibam, my time when I was a student. He studied the highest level terrace, and we call this T3 terrace. And then he found that this terrace, the age was 40,000 years, the evidence using carbon dating. Then at the sea level drop, we had the formation of this T2 terrace. And I studied this for my PhD in Ghent University and graduated in 1982. Then, of course, this is the present terraces, riverine, where you got flood every year. Then plenty of people study this. You see, there was a change in landscape throughout history. And of course, there will be changes in soil fertility, and surely agriculture has changed, and also civilization. Okay, let me see this. Remember just now I told you about sea level drop 100 meters below the present height. And then that time there was a period of exposure of big land area, call it Sundaland. This was coined by Molygraph in 1921. He published a paper in 1921 and mentioned about this. Then there was another geologist, Scrivener. He was the director of geological survey in Malaya. In 1931, published a book on the geology of Malaya. He mentioned same thing, mentioned with all the evidence of the salinity drop and the exposure of Sunda. So I want to, when there was land like this, I see river. I want to show you this particular river. See this river that has joined and come here. This the Malay Peninsula. This is Sumatra. Then that river draws its water reaches in the mountain of Malaya. Okay. Check this carefully. Then this is the present Peninsula of Malaysia, where you got South China Sea and the Strait of Malacca. See that river just now is this one, which is Moa River. But that river go there, stop there. That the upper reaches has been captured by another river. This river is called Pahang River. So now the water upper reaches of older river is now been drained into the South China Sea. So that river has been captured. When it took place, it is about this case. Well, many years ago. And the area there between there and the area become a lowland, swamp, tasik chini, tasik bra. Then, see, the landscape has changed. And then, in the 14th, 15th century, Malacca was an empire. There was a Malacca. Then there are people who wanted to take a shortcut to China or Thailand. So they took a boat to this river and then went up. And then they want to go to another, the former river. That's about any distance about 300 meters at a place called Penari. And they asked people to carry the boat to the other side and straight the river and gone to the Pang River, and they went to China or Thailand. So there was a shortcut. That happened. So you see, the change has taken place with a lot of soil being changed. Agriculture has been changed because of this change in river system. All right, now this is the map of the Malay Peninsula. You see that near the coast, you see the gray color. This is the recent deposit, aged between 8 to 5 to 6,000 years. And some of these actually acidic. They are actually marine in origin, but clay. And you go to the East Coast, we also have this marine deposit of the same age, but sandy in nature. And there were two different processes have taken place that make it sandy, and they want to make it clay. I'll come back to that later. Now, as you can see, it's the red color. These are granite. The Malay Peninsula actually composed of about 50% granite, and two different colors of granite. This granite has a bit different from that granite, and this one we got a lot of tin. For 100 years, the British miners have been mining tin here, and they brought Chinese from China to be tin miners. So see, the landscape of the country has changed. The soil of the Malay Peninsula, and also agriculture. Okay, now let's go back in time to 4,300 years ago. So we believe that the sea level at that time was 3 to 5 meters above the present height. So when that happened, then when there was a flood, along the coastal region, and that flood of water result in soil acidity. I will come back to that later. And there are evidence to show this. You see this in Peninsula of Malaysia. We see this in other Southeast Asian countries, including Cambodia. So this is the proof. So if you go to the northern Malay Peninsula, near the Thai border, this is Andaman Sea. You see an island there? The sea has been cutting. Call it wave cap notches. And we believe that this is also wave cap notches. I mean, about 4 to 5 meters above this level. And it was the sea before. Remember, if that happened, I mean, the area along the coast, the island, the Malay Peninsula, and other parts of the region or flooded by the sea. Okay, one proof. The other proof, one of my colleagues studied this in Ghent University, PhD, in 1980. He found this animal 4-5 kilometers away from the sea. This is sea animal. Whenever you see this, then you see pirate, pedogenic pirate. So that means the area was once under the sea and pirate was formed because of the sea level. Remember, we have sulfate on the sea, become sulfide, then ferric on the land become ferrous, and ferrous and sulfide join up to form pyrite. And that caused a lot of acidity to the soil. That's a proof. So then another friend of mine also studied in Ghent University, graduated in 1982, few months ahead of me. He studied the peninsula near southern Thailand. Remember the island just now is there, it's Sri Malacca, and this area was marine alluvial with some pyrite with a lot of acidity. So our major rice field in Malaysia is this region. So the fertility of rice was affected by acidity. Then a student, PhD student of mine, studied this in the East Coast, South China Sea, there, the southern Thailand, the state of Kelantan, and she draw a line. We use, you remember, we use pyrite as evidence for sea level rise. Remember, I published a paper on this using pyrite as evidence for sea level rise, and I published in Bulletin Geology Society of Malaysia. To the left, no pyrite. To the right, we have pyrite. So we could draw a line, and that line really represents the sea 4,300 years ago. And you see the landscape has been changed. Some are sandy with, sand, the other with clay, with some acid. So the landscape has changed, soil fertility has changed, and agriculture has changed. All right. So what happened when you have pyrite? So when you want to, when the sea level pyrite was formed, when you want to use the land, you have to drain the water. When it happened, pyrite changed within 2 weeks to another mineral, yellow in color, called jarosite. Whenever you see this, you know the pH will be about 3. When pH 3, you got problem with aluminum 3 plus and iron 2 plus acidity, cause acidity, right? And we have to settle this. Otherwise, we cannot grow rice or any other crop. Okay, let's go and see geology map of Southeast Asia. You see this area just now, color different, marine alluvial with acidity, 400,000 hectares in the Malay Peninsula. That kind of soil, acid sulfate soil. It's a bigger area in Bangkok Plain, more than 1 million hectares of this acid soil in the Bangkok Plain. I know that because some of my friends from Sasha University studied this, published paper, American, Dutch, they study. And bigger still in Vietnam. Cambodia, Mekong Delta, more than 1 million. Been there in 1992, there was a conference on acid sulfate soil. I was there, I saw the grow rice logi. And then you see, Indonesia has a big area of acid sulfate. One of the biggest area is this in South Kalimantan. 2 of my students went back and studied this acid soil there. For rice, very difficult. So now I have a conference online on 8th of June, and Nanjing Agricultural University organized it. And I told them, if we can convert this land, acid land, into good land to grow rice, then we solve the problem of food security. We have to work together, ASEAN and China. Come back to that later. Okay. Now there's another soil, which are very sandy, east coast of Peninsula Malaysia, South Thailand, and also in Indonesia, Kalimantan, call it RIS, fish ridges interspersed with swale. What does it mean? You see this in a lot of areas, including Cambodia and Malaysia. This is what happened. See, one professor In 1969, I was a student of Professor Hale. He was head of the department, well-known geologist. He studied this. The ridge was formed by the sea, of course. I had no time to explain it. You can check in my book. And he said, this first ridge along the coast was formed about 5,000 to 6,000 years ago. When the sea receded, then you have formation of this. Then in between is the lake. And then another one. This is the present sea. You see, as a sea receded, and the formation of 3 ridges running parallel to the coast. These are very sandy. And then when you have sandy soil, then for the soil. See, there is 6,000, there is 3,000, this is the current one. Okay, what happened? So we go back to South China Sea. This is South Thailand. This is Kelantan River, state where I was born. And they believe that the Kelantan River was there before. This is the present map. Then another professor, Professor Chia, well-known geologist who studied this, published many papers. Then his team said, the river, this is the present river, this is the old river. Then the Kelantan River has moved that way 35 kilometers in geological time. When it happened, also is not. So the landscape here has been changed. Soil has been changed. Agriculture and human civilization also changed within the period. Okay, let's look at what happened to the sandy soil. Daytime 40 degrees C. Sand content 90%. There's no soft moisture. Extremely difficult to. Big area in Peninsular Malaysia, big area in southern Thailand, Cambodia, and Kalimantan. So I told again to the researchers in Najib, I told them if we can convert this land and we can grow a crop, then we can solve the problem of food security in the long run. So ASEAN and China have to work together. Okay. How to manage the acid one? Now, this is extremely difficult. I'm spending 30 years of my life working on this soil. So you want to use the land, you have to remove it, acidity. And then they put, because this problem of aluminum and iron, and then you have to add lime or you burn basalt. And the other one is not enough. You have to put a biofertilizer that has micro phosphate solubilizing bacteria. And that's sulfate solubilizing bacteria can increase pH, can produce acidity that can remove all the problems. So we have a solution. And this, I'm not talking, I published in PLOS ONE, proven correct. Okay, that's what happened. One of my students studied is just control only fertilizer. Then put some lime with fertilizer. With lime, see, you get crop of 4 to 5 times per hectare. This one, less than 2. So that shows that if you increase the pH, you get crop rise. Okay, if you don't like lime, one of my students use basalt as a rock. Basalt is a silicate that has olivine. When olivine dissolved, it can produce OH, then increase the pH. Then also the hydrolysis of a silicate produce silicic acid that can help enhance rice growth. It can prevent some disease. That's a good part of it because it produces some nutrients. No problem of heavy metal. So with basalt, without basalt, with basalt. You see, you get yield. So that means increase the pH, you get yield. Because when they increase pH to above 5, all the problems need to be removed. Okay, now I spent more than 3 years working on that thing. We got a PhD student, we have postdoc, and the final one, because we want to produce that fertilizer, biofertilizer that can use in acid sulfate soil. The final experiment was big experiment, only 2. Fish rice, fertilizer, and then fertilizer with some lime, biofertilizer that contain the micro. Then optionally was product from only. At the end of it, control that. But this one, see, produce rice. So that means are able to solve the problem of fertility for rice production on acid sulfate soil. But if can do in Malaysia, can do in Thailand, which is a big area, can do it also in Cambodia, Vietnam, and then in Indonesia, Kalimantan. See, and I told the Chinese, if we can, but unfortunately, it was 1980, and then this pandemic came, 2.5 years in the lab, so by microbes in the lab. But so we know already we can get back, and we can produce, pattern it, produce in China, produce in here, and we can solve the problem of acid sulfate soil to grow rice. Okay, so the detail of what I say is in this book, acid sulfate soil, I published last year. Also the breeze soil, you can have it. You can read this. All right, that was in the past. In the future, I'm sorry, because temperature is on the rise again. And future, maybe already for the last 100 years, maybe gone up by 2 degrees. And we believe that Malaysian government, with the help of California Institute of Meteorology, believe that 80 years from now, year 2100, the sea level in Southeast Asia can be as high as 0.5 to 1 meter above the present height. That is the dilemma. We are going to trouble. This is the proof. If you go, this study has been done in Tokyo, measured temperature in November, sea temperature on the rise, 100 years, started 1890 to 2020. So if you go to Malacca, you see the sea level is going up, see the stubborn trees that can show up. East Coast, you go to November, you see this, the water has gone up inland. There you see it again. This is the south. Singapore at the other end, the southern tip of the Asia. You go there, you see, I used to work here 30 years ago, and now it's gone into the sea. So this is going to have problem. So 3 weeks ago, I went to Terengganu, south of Kelantan. This hotel I stay, and see the government already putting this block of rock just to prevent the sea. So this we have to use it. We have to do this, otherwise the country, the hotel will be destroyed in no time, 20 to 30 years from now. All right, even somebody have to predict by 2050, 30 years from now. So you remember the South Thailand that I showed you just now, and they believe that 30 years from now, the sea will flood the land just like it was 4,300 years ago. Go south a little bit, Kuala Lumpur there, see our biggest port here, be flooded by the sea by that time. Okay, now, what happened to us? We believe that 80 years from now, temperature will be up at least 1.5 to 2. We flood the land. And we believe that by 2100, 80% of the rolling coastal region in Malaysia will be expected to be inundated with the sea, destroy most of our, rice field. So if it happens in Malaysia, it will happen in Thailand, Cambodia, Indonesia, everywhere, China even. So what do we do? Well, we just cannot sit down and say, we have to do something. Maybe we're going to do something. Is try to get a rice variety that can grow in the area flooded by the sea. The China has been starting doing it. I know Nanjing and Chomsky is doing it. And we have signed a MOU, UPM. Hopefully, many years from now, we get a variety that can grow. That at least that's something that we can do. So, conclusion. Climate in Asia kept changing since 50,000 years ago. When there is a pressure up and down, followed by sea drop or sea rise. And that changed the landscape, geology, and soil of Southeast Asia. See, and that phenomenon had great impact on soil fertility, agriculture production, food security, and trade. So that will happen. So hopefully, what I said, you got a message true. Okay, thank you.